Okay. So quotients for today is what we're looking at. That's the answer to a division problem, right? So by definition, a quotient is the answer to a division problem. That should be a. It's the answer to a division problem. Now, at this level, you're going to see things written like this. You will not see that anymore, okay? This way is now obsolete after about pre-algebra, okay? You will see this method only. Now, to best explain how to do division, there's two methods. Method one, which what you've already learned, is to simply divide it. So 6 by 2 is 3. So we cut 6 into two groups. I know this seems easy, but I want to explain it so you understand it. Is 3 per group, right? So that's the third grade level explanation. The one that I want you all to feel out is the reciprocal definition. So 6 divided by 2 can be accomplished by taking 6 and multiplying it by the reciprocal of 2, which is a half. Okay? So this activity, take dividend, first number, and multiply it by the reciprocal of the divisor. Okay, so just to really quick, this is the dividend, this is the divisor, and this is the quotient. Okay, so instead of performing the division, you can multiply by the reciprocal of the divisor. And knowing that helps in some of the more difficult divisions that we do. Obviously now you're kind of thinking that these are easy enough that you don't need to do that, but we're gonna look at that anyway. So here's example 1. These are my examples. These are not going to be in your book. If I simply say to you 16 divided by 2, which you know I'm not going to write it that way anymore, you can either perform the division, right? So this is using division, or you can multiply by the reciprocal, which would mean 16 times a half. Either way, in the end, you all know you can do it either way. Most of you are not going to do this when you can simply cut it in half in your head. Okay? Whether or not you're dividing positives or negatives, the rule of multiplying by the reciprocal remains the same. Say I did negative 24 divided by negative 8. Assuming I wanted to use the reciprocal thing, negative 24 over 1 multiplied by negative 1 over 8 is still going to result in a positive 3, right? Because we use the multiplication properties that we've learned. Negative times negative is a positive. Okay? Finally, we can utilize it when we have a really rough fraction. And this is something that I feel like is super handy. 15 divided by, actually no, that's not what I wanted. Hang on, wrong. I want to give you mine. Hang on. 64. Trying to make one up. Not doing a very good job. Yeah, no, I'm trying to make one up so that it works the way I want it to work. 36 divided by 4/5. Okay? 36 divided by 4/5. Instead of performing that as a division, which you know we never do, you've been learning that for years, we multiply by the reciprocal, plugging in a 1 where necessary, and reducing by a factor of 4. Did you end up with 45? Okay. I just used a couple of positive numbers there. Now, below that, so we did the definition of division and how it can be accomplished, either normal division or multiply by the reciprocal. Below that is a gray box which gives you the rules for division. Okay, I'm going to flip, and it looks like this. So, dividing and answer. Same sign is always going to be a positive.
Catherine, can you join us in the office, please?
If you divide the same sign, it's always going to be positive, right? -6 divided by -2, we learned, is a 3. +12 divided by +4, we learned, is still a positive, right? Those are just a couple of examples. In contrast, if you have different signs, your result is a negative. So -6, +2, 12, -4. Okay, so same sign samples, different sign samples. Dividing same sign is a positive quotient. Dividing different signs is a negative quotient. Example 2 simply has you now not only using the order of operations, but it also has you using this methodology, okay? And I'm going to give you my example 2. Okay, this one is mine, and it goes something like this. Yes, this is a toughie. Okay, so the difference of 2 and -15 multiplied by 7 added to 1 is going to be the dividend. So 2 and 15, -13. -13 times 7, calculators please. -91? -91, add 1, did you end up with a -90? Yeah. Okay. Awesome. -6 squared is 36, correct? Positive. What is the opposite of positive 36? Negative. Good deal. So -36 cut in half is going to give us our new divisor. What is our -18 is correct. Okay, after doing all the labor in the numerator, all the labor in the denominator, I now have a division problem that is going to result in a positive or negative answer? Positive. Did y'all come up with 5? Okay. That is kin to example 2 in the book. You can distribute division a little bit. Okay, and I'm going to show you how it works. And this to me is one of the clunkiest thought processes for people to understand. So let's just say I said the sum of these two numbers divided by something else. Bada boom, bada bing. I can take this and say, okay, if I divide A by C and add it to B by C, I have the same exact thing. Okay? These two items illustrate how you can distribute division. It's almost like the opposite of distributing when we think of it in terms of multiplication. You know how I draw those little hooves to kind of show? Well, what we did, instead of doing that, we pulled the C out of both pieces separately. Same goes for a subtraction type of thing. If you do this, it's the same thing as taking the quotient of D over F and subtracting the quotient of E over F. And oftentimes doing that makes arithmetic a lot easier. So this is true. Okay? Same divisor, so we simply broke it up. However, look at the caution sign. If the divisor is two different pieces in the caution sign, you cannot do that. So this is a big fat no. Here it is. The no is G over H plus I is absolutely not equal to the quotient of G divided by H added to the quotient of G divided by I. So this is the huge caution and warning light for you. Okay, this is a big fat no. And you can actually see it if you actually fill in some numeric values. Like let's just say 14 divided by 2 plus 5. Okay, you all know the answer would be 2 because it's 14 divided by 7, right? If I did 14 divided by 2 and added it to 14 divided by 5, 7 plus whatever this is, 2 point something, does not equal what this does, okay? So be very cautious. Only distribute out if it absolutely works, and that's what example, or the gray box there shows us, okay? Example 3 is an excellent use for this, and I'm going to go ahead and show you an example 3 that I have. This is not theirs, so remember, look back in the book if you want another one. Example 3, okay? Example 3 looks like this. Negative 10z to the 4th added to 8z squared minus 2. All of that divided by negative 2. Okay? Most of you probably already in your head can solve this, but to do this using the distributive method, you would break it up. Everything divided by negative 2. Use the operators to combine the results. Okay? Say again? You good? The result is going to be what? Positive? Yep. Exactly right. Okay, you guys have already done this in Algebra 1 in some capacity or another, definitely. Okay? Let's take a look on page 35, and I want to do 2 more things with you. I want to do numbers 25 and numbers 27 with you. All right? Evaluate, maybe only number 25. Evaluate for the given values. Okay, here's number 25. It says y times y minus 3 divided by, everybody should be taking notes. If you're just sitting there, something's wrong. Okay, the first one, A. What if y is negative 1? How about positive 1, Mrs. Myers? That's what it actually says. So plug in that 1. 1 times 1 plus 3 minus, Jiminy creaminy, my pen. Y equals 1. All of that over 1 minus 2. Okay? So that becomes 1 times negative 2 divided by negative 1, right? To get from here, we take that, which is a negative 2. Figure that out. I can now say it's negative 2 divided by negative 1. In the end, your answer is a 2. Okay? Be very, very careful. Number 1, that you don't copy it wrong, because that's always my biggest mistake. I copy stuff wrong. Letter B, what if y equals a positive 4? Plug in the y value. 4 times 4 minus 3 over 4 minus 2. So instead of having a 1, we now have a 4. 4, 1, 2. 4/2, same answer, different numbers. Okay, you guys see how all that worked? Letter C. Last one. What if y equals 3? Okay. 3 minus 3, 3 minus 2. Some of you right at this point might already know the answer, because anytime you multiply something by a 0, the end result is 0, and 0 divided into one group is still 0. Remember, we can have a dividend of 0, but not divisor. You can't divide something into 0 groups. That's called magic. Okay? That's called magic, and that was Houdini's gig, not mine.